So in last class we started sequence and series. So this is the second lecture of sequence and series. So first we will recall whatever we had done in the last class. So as I told, what is AP first? So it is A, we have to add by a fixed number, so we are taking that fixed number as D. So we have A, then the second term A plus D, A plus 2D, third term. In third term the coefficient of D is 2, which is 1 less than 3. So in the nth term it will be A plus n minus 1 into D. So in this first term is A and common difference is G, and general term we got that is A plus n minus 1 into D, and sum of first n term also we got n by 2, and we have proof for that also. So we have seen this one. Next important points, Tn can be written as Sn minus Sn minus 1. So those things we have seen. So in this class we will start. So we will start the important observation. This is the 8th point, important observation. We will see this important observation in sequence and series. See, I am taking Tn. Tn, as you know, the nth term of this AP is A plus n minus 1 into D. So now what I am doing here is, this D is common for both the terms. I am multiplying this inside. So if I multiply this inside, I will get A plus nd minus D. Now I can write this as nd plus A minus D. So this will be Tn. So just I am simplifying this. So I got this value as Tn. Now if you see this, Tn is a linear function of n. Tn is nothing but linear function. And you know what is linear function? The highest power of the variable will be 1. So here variable is n is the variable, because n is keeps on changing. So linear function of n. So or I can write this Tn as alpha into n plus beta. Now the coefficient of n is alpha, which means alpha, I got this alpha as what? N. I got this alpha as, I got this alpha as D. Alpha as D. From comparing this I am writing. So alpha will be equal to D, which is the common difference, So coefficient of that n will be the common difference. Now this beta will be nothing but A minus D. So how I am writing this? From comparing this Tn equal to nd plus A minus D. So here I have written alpha into n plus beta. So now if you compare the coefficient of n, here also n and here also n we have. The coefficient of n is alpha here, and here I have to take the coefficient of n, which is alpha equal to D. So what I am telling here is, if I have taken suppose Tn equal to minus 5n plus 8. So this will be AP, because it is linear function of n. So in this linear function of n, so if I have to find the first term and the common difference, I can compare with this alpha n plus beta, Tn equal to alpha n plus beta. Here this alpha is nothing but D, I told you here, in this I have written, and this beta is nothing but A minus D. Beta is nothing but A minus D. Now comparing from this, what I can do here is, I can write alpha equal to minus 5. I am just comparing with this Tn minus 5n plus 8 in alpha n plus beta. So beta, I can write that beta as 8. Now what is alpha actually? It is just D. So D equal to minus 5 I got. So without expanding this, without writing the AP, we can able to find the common difference. Now this A minus D equal to beta, so A minus D I got this as 8, and already we got the value of D as minus 5. So A minus of minus 5 will be equal to 8. So it will be A plus 5 will be equal to 8. Now A will be equal to 8 minus 5. So 8 minus 5, you know, it is 3. So I got the first term and I got the common difference. So this is what we have to find, and this is one formula method. Directly also you can go. So how we can go directly? T1 is nothing but first term A. So in this T1 substitute the value of n as 1. So minus 5 into 1, it is minus 5 plus 8. So 8 minus 5, 3. So I got the value of A as 3. To find D, you need the second term T2. T2 will be equal to minus 5 into 2 is this minus 10 plus 8. So T2 will be equal to minus 2. Now this d is nothing but t2 minus t1, which is minus 2 minus 3. So d will be equal to minus 5. So same thing we got here also. Now I can tell the important observation what we have seen here is Tn is nothing but linear function of n. So you cannot see Tn as like this 5n square plus 7n. This cannot be Tn. The general form of Tn cannot be like this 5n square plus 7n. So it is linear function of n. So alpha n plus beta will be there, where alpha is equal to the common difference, which means the coefficient of n whatever you have, so that will be the common difference, and whatever constant term you have, so that will be nothing but a minus d. So from this itself you got the common difference. If you substitute that here, you will get the value of the first term as well. So now the next observation, B part. So Sn, I will come for Sn. So Tn we have completed, now I will come for Sn. So Sn can be written as n by 2 into 2a plus n minus 1 into d. Now this same thing, I am just calculating this 2a, d is common for both n as well as minus 1. So plus dn minus d. Next what I am doing, I am multiplying this n by 2 inside. So if I multiply this n by 2, I have to multiply to this term, as well as I have to multiply to this term, as well as we have to multiply to this term. So now what I can do, I can cancel this 2 and 2, I can write this as an plus this I can multiply, I can write n square by 2 into d, so minus n d by 2, like this I can write. Now just what I can do, I can write d by 2 n square plus a minus d by 2 into n, because here also I have n, here also I have n, and here also we have n. So now what I can do here is, this is nothing but Sn. So here I can write this as Sn equal to alpha, because d by 2 is some constant, n square plus beta n. So now what I am going to tell here is, Sn is nothing but quadratic, because the degree is 2, quadratic in n with 0 constant part, with 0 constant part. So constant part, we do not have the constant part, so constant part will be 0. So you cannot get the Sn as like this 4n square plus 3n plus 7, like this you cannot find any Sn, because the constant term should not be there in Sn. Plus 7 you will not get, or any number except 0 you will not get. You will not get minus 1 as constant separately, you will not get minus 2 separately. In Sn, sum of n terms of AP only we are discussing, and here in this if you compare, this alpha will be equal to d by 2. Alpha will be equal to, after comparing, alpha will be equal to d by 2. Now this beta is nothing but a minus d by 2. Beta is nothing but a minus d by 2, and alpha is nothing but just d by 2. Now just I will write whatever we have discussed. So Tn is nothing but alpha n plus beta, and Sn we have written in this form alpha n square plus beta n. Now in this alpha n plus beta, here alpha is equal to d, and this beta is nothing but a minus d. And in this alpha n square plus beta n, so here alpha is equal to d by 2, and this beta is nothing but a minus d by 2. So now with the help of this result, we can do one question now. So example, if Sn equal to 5n square minus 11n, find a, d, tn. See here, with the help of observation, also with the help of I can write S1 equal to a, I can easily find, and S2 is nothing but first term plus the second term. From here also you got T1 and you got T1 plus T2, so easily you can find the second term, which is second term is nothing but S2 minus S1. Then D you can find T2 minus T1, like this also you can do, or with the help of this result. So now from here Sn compare with this alpha n square plus beta n. Now alpha is nothing but 5 here, and beta is nothing but minus 11 here. And you know very well alpha is nothing but d by 2, d by 2 equal to 5 we have, which is the common difference will be 10. For this AP the common difference will be 10, and beta is nothing but minus 11, so which means a minus d by 2 equal to minus 11, and d is 10, so a minus 5 equal to minus 11, so a will be equal to minus 11 plus 5, and minus 11 plus 5 is what? Minus 6. So we got the first term as well as we got the common difference. With the help of this easily we can write the AP. I can write minus 6, and minus 6 plus 10 4, 4 plus 10 minus 6 plus 10, so it will be 4, and 4 plus 10 14, 14 plus 10 24, and after that it keeps on going like this. So this is one method, like this we can do, or there is one alternate method. So that method is nothing but Tn, any term, nth term I can write in terms of Sn. If sum of n terms if it is given, if you want to find Tn, so it is same as Sn minus 1. Now S1 is equal to A1, which is 5 minus 11, because Sn is given as what? 5n square minus 11n, 5n square minus 11n. I will copy this again. So S1 will be equal to 5 minus 11, it will be minus 6. So this will be same as T1. And S2 will be equal to 5 into 2 square 4 minus 11 into 2. So it is 20 minus 22, it is minus 2. So this is same as T1 plus T2. Now what I got here is, I got minus 2 equal to T1 is same as minus 6 plus T2. Now from here T2 I got 6 minus 2, it is 4. So from here you will get the value of T2 minus T1. So T2 is 4 minus T1 is minus 6. So 4 minus of minus 6, 4 plus 6, so it is 10. So I got the common difference as 10, and I got the first term as minus 6. So after that easily we can form the AP. So there are two methods to do this one. Okay. Now we can solve some of the questions. So the first question. So if Ti belongs to AP, so which means T1, T2, T3 up to Tn all are belongs to AP. So and they have given one information, T1 plus T5 plus T10 plus T15 plus T20 plus T24 equal to 225. They have given this information. What we have to find? Then find S24. Sum of 24 terms we have to find. Sum of 24 terms we have to find. Now just see this one. This lower suffix 1 plus 24 is 25, and here 5 plus 20 also 25, and here 10 plus 15 also 25. I told you if lower suffix, if the sum of lower suffix if it is same, then that sums, which means T1 plus T24 will be same as T5 plus T20 equal to T10 plus T15, because for all the lower suffix sum is 1 plus 24, here 25. If same, if it is coming 5 plus 20 again 25, which means this will be equal, and here also the same thing 10 plus 15, so it is 25. Now I can write this as 3 times, because T1 plus T24 I'm clubbing this one, so I can write that as 3 into T1 plus T24. Why I am writing? Because T5 plus T20 I can write that as T1 plus T24 itself. T10 plus T15 I can write that as T1 plus T24 itself, and equal to 225 they have given. So now T1 plus T24, so 225 divided by 3. So after cancelling 3 7s are 21, 1 carry 5, so 75 will get. Now we got T1 plus T24 equal to 75. Now what they are asking, S24. So S24, this is nothing but n by 2 into first term plus last term. Sn I can write. Sn I can write n by 2 into first term plus last term. first term plus last term. So this will be equal to n by 2, first term which is T1 and last term which is T24, and n is what? 24 here. So S24. We got this one. And T1 plus T24, we already have this one. So just we have to substitute this. So 24 by 2 it is 12 and here 75. So 12 into 75 it is 900. So we got the sum of 24 terms as 900. Okay. So the next question, second, this is the answer. So now let Sn, second question, let Sn denotes sum of n terms, and they have given S29 equal to 3 times Sn, then find S3n divided by Sn. They are asking the ratio now. Now first what I will do here is, this S29 is nothing but sum of first 2n terms, sum of first 2n terms of AP, because they have mentioned sum of n terms of AP, sum of 2n terms of AP, which means S2n divided by this Sn. If it comes here, I can write Sn here. So equal to 3 divided by 1 we have, 3 divided by 1, because if nothing is written in the denominator, it is understood 1 is there. Okay. So now you know very well Sn is nothing but, it is quadratic equation with 0 coefficient. So Sn is nothing but alpha n square plus beta n. Now instead of Sn we have 2n, instead of n we have 2n. If you compare this, instead of n we have 2n here, which means in place of n I have to write that n as 2n now. So S2n will be equal to alpha, in place of n 2n the whole square plus beta into 2n. So now this will be same as 4 alpha n square plus 2 beta n. Okay. Now just substitute that here, S2n divided by Sn we have. So it is 4 alpha n square plus 2 beta n divided by alpha n square plus beta n, and this is what they have given us 3 by 1. Now from here what you will get, just cross multiply this. So you will get 1 into anything is 1 only. So 4 alpha n square plus 2 beta n, and this entire thing into 3 we have. So which means 3 alpha n square plus 3 beta n we have. So from here what I can do here is, I can take everything to the left hand side and this beta n I can bring to the right hand side. So 4 alpha n square minus 3 alpha n square, it is just alpha n square equal to beta n we have. So we got this relation now, alpha n square equal to beta n. Now what they are asking first, they are asking S3n, sum of 3n terms divided by sum of n terms. So now I will come here. So S3n divided by Sn they are asking. Same thing in Sn we have alpha n square plus beta n. In place of this n, now substitute 3n. In place of this n, just substitute 3n. So we have alpha 3n the whole square plus beta into 3n divided by same thing alpha n square plus beta n. Now this is what we have to find here. Whatever answer we are getting, that is what we have to find here. Now just simplify this, 3 3s are 9. So 9 alpha n square I have plus 3 beta n I have divided by alpha n square plus beta n I have. So just now I got one relation. In place of this beta n I can write alpha n square. In place of this beta n I can write alpha n square. And here also n square is there. In place of beta n I can write alpha n square. Now from here can I write 9 alpha n square plus 3 alpha n square, because beta n can be written as alpha n square. Now here also alpha n square, beta n can be written as alpha n square. Now I got 9 plus 3 12. So 12 alpha n square divided by alpha n square plus alpha n square, 2 alpha n square. Now from here this alpha n square and this alpha n square will get cancelled. 2 1s are 2, 2 6 are 12. So I got 6 by 1. The ratio of that S3n, sum of 3n terms divided by sum of n terms, will be equal to 6 by 1. So this is what we got. This is the final answer. Okay. This is the final answer. You can copy this. Okay. We can go to the next question now. So now this if S1 is equal to set 1, S2 equal to 2 3, okay, S3 equal to 4 5 6, S4 equal to 7 8 9 10, and it keeps on going, so on. Then find sum of all the elements of S23. So whatever elements we have in this S23, first we have to find that. After finding the elements of S23, we have to add all the elements of S23. Now if you compare this here, S1, I got this as 1. S2, from after this 1, whatever number we have, we are starting from there. 2 3. S3, so after this 3 4 5 6, we are starting from here. So like this it will keep on going. Then S4 will be equal to, so it will be 7 8 9 10. So as well as S5, like this I cannot write till S23, it will be very big number. Okay, so we don't have that much of time in JEE exam. So S5, so it will be 11, 5 terms will be there, 11 12 13 14 15. So like this it keeps on going. So what will be S22? First we will find that one. And what will be S23? So this is what we have to find. So if you clearly see, in this S1 only one number is used. In this S2 two numbers are used. 2 3, two numbers are used. In this S3 three numbers are used. So what we have to find, till this S22, how many elements, how many numbers are used? We have to find that one, because we have to find the starting number of this S23. How many numbers are used here? That we have to find. How many numbers are used here? So this is what we have to find. Okay. So now for this, what I can do here is 1 plus, here only one number is used. In first term, in S1 only one number is used. In second S2 two numbers are used. In third 3 number are used. Like this it keeps on going. In S22 22 numbers are used. So if I add this, I can able to say how many numbers we have used. So this is nothing but sum of 22 terms. So it is n by 2, 22 by 2 into first, then first term plus last term. So it will be 11. So 11 into 23. So it will be 253. So till here we have used 253 numbers. Till here we have used 253 numbers. In S23 we will have 254 and it 255, and it keeps on going like this. And I know the value of n will be here 23 numbers will be there. Here 23 numbers. I will repeat this again. So in S1 we have inside the set we have just one. In S2 we have 2 elements inside the set, 2 3. In S3 we have 3 elements, in S4 4 elements, in S5 5 elements, in S6 6 elements, in S10 10 elements will be there. Like this, how many elements we have used, how many numbers we have used, that we have to find. In first S1 1 element, in second 2 elements, in third 3 elements, like this. In S22 22 elements. So like this, first I have to find how many numbers we have already used. So it is 253. Okay. So now after this 253, only in S23 254, the last term of this S22 will be 253, here 252, like this it keeps on going. And S20 254 is the first element of S23. Now it forms an AP only. Now what they are asking in the question, sum of all the elements of S23. We found the elements of S23. Now just take this, A will be equal to 254 and N we got 23 and common difference D will be equal to 1. So in Sn formula I can directly use D will be equal to 1, we have N by 2, 23 by 2 into 2A, 2 into A which is 254 plus N minus 1, 23 minus 1, 22 into D which is 1. So now if you calculate this, you will get 6095. So this will be the sum of S23. Okay, in S23 we will have this one. S23 is the said sum of S23 will be this 6095 will be the answer. Now next question. In AP, if SP equal to Q we have and SQ equal to P we have, then find SP plus Q. Here Sn denotes the sum of first n terms. Now how to find this? Now what they have given here, SP sum of P terms equal to Q, which means this will be P by 2 into 2A plus P minus 1 into D equal to Q they have given. So this will be the first equation, we can take this as first equation. SQ equal to P they have given, which means Q by 2 into 2A plus Q minus 1 into D equal to P they have given, second equation. Now they are asking us to find SP plus Q, this is what we have to find. So same thing, P plus Q by 2 into 2A plus P plus Q minus 1 into D. So this is what we have to find here. Okay. Now from the first equation, this 2 I can bring here, this 2 I can bring here, and this P also I can bring here. So what I can do here is, from 1 I can write this as 2A plus P minus 1 into D equal to 2Q divided by P. Like this I can write. 2 will go here in the right hand side if it is in the division, if it go to multiplication, if it is in the numerator it will come to the denominator, P is in the denominator. So now from 2, same thing, 2A plus Q minus 1 into D equal to 2P divided by Q. Now what I can do here is, now I can subtract. So if I subtract this 2A and this 2A will get cancelled. Now D I can take common, here P minus 1 minus of Q minus 1, so it is minus Q plus 1 equal to 2Q by P minus 2P by Q, like this we have now. So now from here what we can do here is, this minus 1 and this plus 1 will get cancelled. Now we will get P minus Q into D equal to, now we can take LCM, 2 I can take common, we can take LCM, Q square minus P square divided by PQ. Now after this, Q square minus P square, A square minus B square, we can use the formula A plus B into A minus B. So we have P minus Q into D equal to 2 into Q plus P into Q minus P divided by PQ. Now after this what I can do here is, P minus Q I can cancel, this will be minus 1 because Q minus P can be written as minus of P minus Q. So after cancelling P minus Q I will get minus 1 here. So now I got the value of D as minus 2 into P plus Q divided by PQ. So this is what we got the value of D here. Now I can substitute this value of D in this P is sum of P plus Q terms. Let me write that again, is P plus Q. It will be P plus Q by 2 into 2A plus P plus Q minus 1 into D. So this will be equal to P plus Q by 2 into 2A. See here, P plus Q minus 1 into D, can I write this as P minus 1 into D plus QD? I can write like this. Now this 2A plus P minus 1 into D, so this is same as 2Q by P. 2Q by P. Now I can substitute that here, P plus Q by 2 into, so 2A plus P minus 1 into D, we have from here 2A plus P minus 1 into D, from 1 I can take 2Q by P. 2Q by P. Now what will be QD? See here, in this D, if this Q alone comes here, so it will be QD. QD will be equal to minus 2 into P plus Q divided by P. So now I can just substitute that here. So it will be plus of minus 2 into Q plus P divided by P. P plus Q by 2 divided by, and now this 2Q by P we have, and here minus 2Q by P we have, and minus 2P by P we have, like this we have now. Now from here this 2Q by P minus 2Q by P, it will get cancelled. Now we have just P plus Q by 2 into minus 2P by P. So from here itself P and P will get cancelled. I can cancel this P and P, just minus 2 will be there. From here this 2 and 2 will get cancelled, so I will get minus of P plus Q. So this will be the final answer. The remaining concept, finding number of common terms of two different APs, so that we can find, that we can do in the next class.